Hello, I am teacher Carla, and for today we will be learning about LCM, GCF, and the different methods on finding GCF. Now let's proceed to the next slide.
To be able to understand better our topic for today, take note of the following key terms: factors, multiples, least, greatest, and prime numbers. In this chapter, you will define multiples, LCM, and GCF. You will also identify factors and multiples of numbers. In this chapter, you will list the multiples of a given number, find the LCM or GCF of given numbers. It is important for us to learn about LCM and GCF because when we will move on and learn higher math concepts, we will encounter most of the time GCF and LCM, especially when dealing with simplifications and advanced operations on fractions. GCF. GCF stands for greatest common factors, sometimes referred to highest common factor. The greatest common factor is the largest number that can divide two numbers. To find the greatest common factor of a number, list the prime factors of the number and identify the greatest. We can solve GCF of a number using three different methods. 1. Listing out factors. In solving for GCF, we can use listing out factors method. Suppose you are given two identical numbers. To solve for GCF, you will list one by one all the numbers that can divide the given number exactly, which are called factors. After doing so on the given two identical numbers, find the greatest number or factors that is similar for both numbers.
Hello everyone, this screencast is going to show you how to find the greatest common factor, or the GCF, using the list method. So you have two numbers here, 12 and 30. The list method is going to be listing all the factors of 12. So I have 1 multiplied by 12, 2 and 6, 3 and 4. Then I'm going to list the factors for 30. So I have 1 and 30, 2 and 15, 3 and 10, 5 and 6. So we're going to list these factors. So the factors for 12 are 1, 2, 3, 4, 6, and 12. List the factors for 30. 1, 2, 3, 5, 6, 10, 15, 30. And if you look at them, you'll see they have 1 as a common factor, 2 as a common factor, 3 as a common factor, but the greatest common factor will be 6. So the GCF, or the greatest common factor for 12 and 30, is 6. And where we can apply this to fractions is if I have a fraction 12 over 30, if I reduce by the GCF, 12 divided by 6 is 2, 30 divided by 6 is 5. I get 2/5, which is equivalent to 12/30, but it's in lowest terms, simplest form. It's my reduced fraction.
2. Factor trees. Prime numbers are numbers which does not have any other factor except for 1 in itself. In solving for GCF using factor tree, you will divide or factor out numbers in such a way that it has at least one prime number. The branches will end once the last numbers can no longer be divided by any other numbers or a prime number itself. After which, compare the factors of the two number and copy the similar prime numbers. Lastly, multiply all similar prime numbers used in factorization of both given numbers.
Welcome to Moo Moo Math and Science. In this video, let's learn how to use prime factorization in order to find the greatest common factor of two or more numbers. The greatest common factor of two numbers is the largest number that divides evenly into both of these numbers. So let's get started. Let's find the greatest common factor of 6 and 8. To begin with, let's start with some factor trees. With 6, let's begin with 2 times 3. I will circle the 2 and the 3 because they both are prime. For 8, I will begin with 2 times 4. I will circle the 2 because it is prime. And then I will multiply 2 times 2 and I will circle both of the 2's because they are prime. So now we have all the prime numbers. The next thing we need to do is create a prime factorization chart. So I will write the prime numbers for 6, which is 2 and 3, and then the prime numbers for 8. I will skip a space where the 3 is because I do not have a 3, so I will write 2, skip a space, 2, and 2. I next will use this rule. Use only one factor from a column if you have a vertical pair. So let's put this into practice. Column 1, we have a vertical pair of 2's, so I will bring the 2 down. Next, for 3, I do not have a vertical pair. The other 2, no vertical pair, or the next 2, no vertical pair. So my greatest common factor of 6 and 8 is 2. I'll continue to work some examples, so hopefully you'll get a hang of using prime factorization in order to find the greatest common factor. And find the GCF of 16 and 24 using prime factorization. So the first thing I'm going to do is create a factor tree. 2 times 8 equals 16, circle the 2. 2 times 4 equals 8, circle the 2, and then 2 times 2 equals 4. So I'm down to prime numbers, so there's all the prime numbers of 16. Now for 24, 2 goes into 12. 24 12 times, and then 2 times 6 is 12. Again, circle the 2, and then 2 times 3. Circle both of these because they're prime. So now I'll create a prime factorization chart. Okay, so we have 16 and 24. So I'm going to write 2. I'll put a check. 2, 2, and 2. Now I'll do the same for 24. So I've got a 2 here. I've got a 2, a 2. Now I have a 3. I'm going to skip a space and write 2. Remember the rule, if you have pairs in the vertical column, since you're using 2 numbers, then you use that. I have a pair here, so I will be 2, and another pair, and another pair. So I multiply these together. 2 times 2 is 4. 4 times 2 equals 8. So the GCF of 16 and 24 is 8. Let's work another one. Okay, in order to speed up the process on this next one, I went ahead and completed the factor tree. So the prime number is 15, 3, and 5, and then for 28, 2, 2, and 7. So now I'm going to create my prime factorization chart. Okay, and so we have 3 and 5. Now we have 2, since I do not have a 2 or a 5, excuse me, there's not a 2 or a 2 here, so I'm going to skip over to here, and the same with the next 2, and then the 7. Okay, now in this instance, I do not have a pair of a vertical pair, so I cannot bring anything down. So in this case, the GCF of 15 and 28 will be 1, okay, because there's not a vertical pair. Next, let's work a couple with 3 numbers. Okay, let's go ahead and find the GCF for 3 numbers. Again, I've gone ahead and completed the factor trees for each of these, so I'm going to complete a prime factorization chart. So I have 12, 36, 48. So for 12, I've got 2, 2, and 3. Now for 36, I'm going to put a check by each one. I have a 2 because this is really easy to make a mistake. I have a 3 here, and then I have one more 3, and I've written all of these. Now for 48, I'm going to do the same. I've got to check for the 2, check for the 2, check for the 2. But remember, notice that there is not a 2, so I'm going to skip a space check for the 2. I'm going to skip a space, and then we have a 3, and I can write this here. Now the rule changes slightly when you have 3 numbers, because you have to have 3 numbers in the column, and if it does not have 3, you cannot use it. So we have a 2, and let me draw a line here. We have a 2, and we have a 3. Now I will not pull down this 3 because there's not 3 numbers in the column, or this 2 or this 2. So now I just multiply 2 times 2 is 4, and 4 times 3 equals 12. So the GCF, so we multiplied these together, of 12, 36, 48 is 12. Let's work one final one. Okay, we have 3 numbers again, 30, 12, 8. Here's the factor tree. Create my prime factorization chart. We have 30, it's a little messy, 30, 12, 8. So for 30, I'll write 2, 3, 5. For the 12, I'm going to put a check. We have a 2. I have to skip a space because there's not a 2 here or a 2 here, so I'm going to move the 2 out to there. And then we have a 3. So I've used all those. Now we have a 2. Okay. I can put a check. I have a 2 here, and then there's no other 2, so I'm going to put this there. Okay, so now I have 3 numbers in the vertical column, so I'll write a 2. I have 2 3s, but not 3, so I can't use the 3. I can't use the 5, these 2s, or this 2. So the GCF of 30, 12, and 8 is 2. I hope that helps with finding the GCF using prime factorization.
Three. Repetitive division. GCF repetitive division is also termed as GCF continuous division and GCF division ladder. To solve for GCF using repetitive division, align the given numbers horizontally. Next, assign a prime number that is divisible to both of the numbers, then divide. Repeat the process until the numbers on the horizontal part are already prime numbers which cannot be divided to other numbers. Lastly, multiply the prime numbers written vertically. The product is the GCF of the 2 numbers. LCM. Multiple is the product of a given number to any positive numbers, such as multiplying given number by 1, 2, 3, 4, 5, but not 0 because 0 is a neutral number. Example 1. The first 5 multiples of 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. Therefore, the first 5 multiples of 4 are 4, 8, 12, 16, and 20. 2. Find the multiple of 5. Since all multiples of 5 are being asked and we know that multiples of a certain number is infinite, then we will use ellipses to indicate infinite number of elements. Therefore, multiples of 5 are 5, 10, 15, 20, and many more. Common multiples are the numbers that can be found in the list of multiples of the given numbers. Example 1. First 10 multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. First 10 multiples of 10 are 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Their common multiples are 10, 20, 30, 40, 50. 2. First 5 multiples of 8 are 8, 16, 24, 32, 40. First 10 multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Their common multiples are 8, 16, 24, and 32. LCM. LCM stands for least or lowest common multiple. It is the smallest positive multiple number that is common to two or more given numbers. Multiple numbers are products of the given number multiplied to any positive numbers. For examples, the multiples of 2 are 2, 4, 6, 8, and many more. The list goes on infinitely. Example 1. LCM of 12, 6, and 4. Knowing the multiples of 12, 6, and 4, we were able to locate multiples that are common for the three given numbers. The common multiple with lowest value is the LCM. Therefore, the LCM of 12, 6, and 4 is 12. 1. LCM of 35 and 10. Listing the multiples of 35 and 10, we will notice common multiples. The smallest number from all the common multiples is the LCM. Therefore, LCM of 35 and 10 is 70.
LCM. What is it and how to find it? For beginners. LCM stands for least common multiple, or the lowest common multiple. The LCM is the smallest multiple that is common to two or more numbers. Since we're dealing in multiples, it won't be any surprise to know that for this, we need to know our multiplication tables. Let's say we're told to find the LCM of 4 and 6. We're going to list multiples of both these numbers, and we're looking for the smallest number that occurs in both lists, that's common to both lists, and that's the LCM. Note down 4 or 5 multiples for each number. Multiples of 4, and just list them in a line. 4, 8, 12, 16, 20, 24. And then list some multiples of 6. 6, 12, 18, 24. I see that 12 and 24 crop up in both listings, so they're both common multiples, but the LCM means the lowest or least common multiple, and the smallest number in both lists is 12. So we simply say LCM of 4 and 6 is 12. That's pretty easy, isn't it? Sometimes you'll be given a set of 3 numbers and told to find the LCM. In that case, we just go through a set of multiples for each of the numbers and find the lowest value that is common to all three sets. Straightforward. We'll find the LCM of 3, 6 and 10. So we list the multiples of 3, and I'm going to have to list quite a few. You'll see why. 3, 6, 9, 12, 15, 18, 21, 24, 27 and 30. And now I'll list multiples of 6. 6, 12, 18, 24, 30. Notice that every multiple of 6 is also in the list of multiples of 3. But we can't pick an LCM yet because we still haven't shown the multiples of 10. So let's do that now. 10, 20, 30. I can stop listing now because 30 is in all three sets of multiples. So it's the lowest multiple which is common to all. The LCM is 30. The nice thing about this method is that you keep a note of the multiples as you go. So you have proof of the LCM because you can see it on the page, and that's great for revision purposes. Teachers love this method as it's so clear. Plus, you get to practice your tables and see the pattern of repeated addition on the page. Basically, it's great for your math muscles. This method is best suited to lower numbers up to 12, since we should know those tables anyway, and that's perfect for students to start with. When we have to find the LCM of larger numbers, there's another way of doing that, and I'll show you that in a different film. Now, go and practice LCM for yourself and boost your math muscles.
Learned that GCF stands for greatest common factor, which means from the list of the factors, the greatest or the largest number is the GCF, while LCM stands for least common multiple, which means from the list of all the multiples, the smallest number is the LCM. Proceed to the next slide and try the activity.